Hi, I am Ashutosh and I am teaching chemistry. Okay, this is lecture 7 of the series of lectures in which we are learning chapter 1 of class 10, that is chemical reactions and equations. Okay, we already finished like all the topics, almost all the topics. In this lecture, we are going to finish the whole chapter. Okay, the topics which we are going to cover in this lecture is corrosion, factors influencing corrosion, methods to prevent corrosion, and rancidity. Okay, which are the, you can say, the final topics of this chapter. Okay, so let's start with this. We all have seen corrosion, huh? Experienced. Okay, so corrosion is the process in which metals are eaten up gradually by the action of air, moisture, and chemical on their surface. Okay, so it means you will learn it in detail in class 12th that air is required and moisture is also required for corrosion. Okay, so it means that the oxidation is there, but in presence of some uh, some very small amount of water, you can say. Okay, so then this corrosion, common examples of corrosion is iron. We have seen the rusting of iron, huh? So all the metals are, you can say, s- are going to react with oxygen and get corroded. So but iron is, you can say, very classical example, very, you can say, we all can relate with. Okay, this rusting of iron. So the iron metal is left in damp air, or dampness is required, okay, for considerable time, and it gets covered with red brown flaky substance, flake it, you can say iron is very strong. Okay, very strong, but even due to this corrosion, it will change into some flakes, which is like which we call rust. Okay, now factors influencing corrosion. Why this, what are the factors responsible for corrosion and all? So more the reactivity of metal, the more will be the possibility of the metal getting corroded. It means that it depends, we can say, factors on which corrosion depends. Okay, factors. So first is reactivity of metal. If the metal is more reactive, then the chances of getting it corroded more, okay, will be more. So reactivity of metal, more reactive metal, okay, will get corrode easily. Okay, second, the impurities help in setting up voltaic cells, which increase the speed of corrosion. Okay, so the impurities, when impurities are present, then the corrosion will occur easily. Okay, increase the speed of corrosion. Then, so we can say impurities. Third, we can write presence of electrolytes in water also increases the rate of corrosion. Again, presence of electrolytes, if electrolyte is present or a salt is present in water, so then what will happen? Then the this corrosion is also a redox reaction. It means that the electrons will be involved, and flow of electrons will be there. Okay, so when we have this some salt, okay, in water, present in water, or some electrolyte present in water, then the, you can say, these electrons, the movement of electrons will be, you can say, very high, and due to this, you can say, the increase, it will increase the rate of corrosion. So we can say that if we have electrolytes present in water, electrolytes present in water, so then like rate of corrosion will increase. Okay, fourth, it says when the iron surface is coated with layers of metals more active than iron, then the rate of corrosion is retarded. Okay, we can say that if we, you can say, put a coat of any metal or any paint or something, okay, on iron, so we can say coating, huh? So then the surface which is going to come in contact with air will not be iron, no more will be, it will be iron. Okay, and that's why the rate of, you can say, corrosion gets increased, or you can say decreased, based on the type of metal we are using as a coating. Okay, then next, a rise in temperature increase the rate of corrosion? Yes, obviously. If the temperature rises, so it means that now the reaction rate of reaction also increases, because at high temperatures, at elevated temperatures, reactions rate of reactions, the speed of reaction increases, okay, with increase in temperature. This is one fact. Okay, so if temperature rises, then you can say uh, iron will get more, we can see more rusting of iron. We'll observe more rusting, more corrosion of iron. Okay, so these are the factors. We can write temperature as fifth, temperature. Okay, so these are the factors influencing corrosions. Okay, next, methods to prevent rusting. How can we prevent rusting? Because see, this corrosion is we can for our economy, for like our monetary loss will be there due to this rusting and corrosion. Why? Like year after year, due to corrosion, there's a lot of iron, okay, getting corroded. Okay, and due to this, there'll be you can say there's a monetary loss, always. So that's why we need to prevent rusting. So what are the methods which we are going to adopt to prevent rusting? Okay, so first is by painting. We used to see that iron doors, iron, you can say anything made up of iron. Okay, we put a coat of painting on that surface, so just to cut the oxygen off of the surface. Okay, so we just need to cut the oxygen off. Okay, and that's how we can prevent the rusting. Okay, so by painting or by applying grease or oil. So if let's say we have a let me draw this. If we have, let's say this is iron surface. Okay, we can put either oil or grease on the surface like this. Okay, like this, to cut the oxygen off, so no oxygen, we are going to prevent the oxygen to come in contact with this iron. Okay, so it means either we can do it either by painting, okay, or by applying grease or oil. Okay, greasing or oiling. Okay, like this we can write, or we can mix this iron with some other we can say metal or non-metal to form an alloy. So by alloying it, we'll be preventing the, like stainless steel. Okay, stainless steel we have. So in stainless steel we have like iron plus chromium. Okay, and that's how we are going to have stainless steel. Okay, it is like there'll be no corrosion, no rusting observed in stainless steel. Okay, then so third we can write alloying, formation of alloy, and by tin plating or chromium plating or zinc plating. So like we can uh, like galvanization, this one. So tin plating, chromium plating, so these are the metals which are less reactive as compared to iron. Chromium plating or zinc plating, that is galvanization, zinc plating. Okay, so these are the methods by which we can prevent the rusting. Galvanization, I should write. Okay, next. So then question, what are the causes of rusting? And the answer will be when acidic substances, including water. Okay, so like how water is going to behave like an acid. So there is like some CO2 present in air. Okay, so due to this CO2, presence of CO2, it will form H2CO3 or not, carbonic acid, and this H2CO3 then dissociates into H plus and HCO3 minus, like this. So due to this H plus, this water present in the form of, let's say moisture, okay, or even like in some other form. Okay, so then this water will behave like an acid, because of the this CO2 present on the in the atmosphere, in the lower part of the atmosphere. Okay, so when acidic substances including water come in contact with metals, such as iron or steel or anything. So then rust begins to form. Okay, rust is the result of corroding steel after the iron particles have been exposed to oxygen and moisture. Okay, oxygen and moisture, both things will be required. Okay, oxygen as well as moisture for this rust to occur. Okay, now rancidity is like is associated with the food items, the condition produced by aerial oxidation. It means that we have food items, okay, and due to the oxygen present in air, okay, it gets oxidized. Okay, so the condition produced by aerial oxidations of fats and oil in food marked by unpleasant smell and taste is called rancidity. Okay, so due to the oxidation of these fats and oil present in our food items, okay, uh, we'll get we can say unpleasant taste, unpleasant smell, and this is called rancidity. Most common example of rancidity is like potato chips made in oil. When exposed to air for a long time, these potato chips start giving unpleasant smell, unpleasant taste. So they are called now that rancid items. Okay. So this is rancidity. And how can we prevent this rancidity? So we can prevent rancidity by adding antioxidant. Okay, antioxidant are the substances which are going to reduce the speed of oxidation. Okay, or you can say check the oxidation, prevent the oxidation part of the food. Okay, so antioxidant we can mix, or storing food in all airtight containers to slow the process of rancidification. Why? In airtight containers we are actually cutting the oxygen off now, we are actually cutting the oxygen off. Okay, and that's how we, if we store the food in airtight containers, we can slow down the process of rancidification. Okay, third, refrigerating food also helps to slow down rancidification. Why refrigerating food? By refrigerating the food, by decreasing the temperature, okay, we are actually decreasing the rate of rancidity or not, rate of, you can say, reaction or not. So at lower temperatures reactions slow down. Okay, and that's why refrigerating the food also helps to slow down the rancidification process. Okay, then next, replacing oxygen in the container with another gas. Okay, for example, to prevent chips from turning rancid, chips manufacturers flush the bags with nitrogen gas. Okay, so obviously oxygen is more reactive and nitrogen is not that reactive. So if we can say replace the oxygen with nitrogen, so then the reaction will be slower, or you can say it is not going to react. Okay, and that's how we can prevent the rancidification of the food items. Okay, so for which purpose rancidity term is used? Rancidity is used for explaining the oxygen levels in the oils. It is also used for explaining the oxygen damage in food. Okay, as the natural structure of the food gets disturbed when the oxygen molecules interact with the oil. Why? Because then reaction will occur. And food resulting in change of odor, taste, and is not advisable for consumption. So these are the you can say things which we are going to look upon if we want to prevent the rancidification of our food. Okay, and so this was all about the this chapter, chemical reactions and equations. Okay, I hope you learned like everything in very much detail. If you have still have any query, any doubt, okay, you can post it on our forum. We are going to answer all your questions, all your queries. Okay, so this is all for now. I hope you enjoyed it. Okay, learning from ask IITians. Okay, and so this is all. Thank you. Keep learning from ask IITians. I hope you people are doing good, and all the best to you all, huh? Thank you. Thank you.